In this video, I will show you how to use the chain rule for finding the derivatives and when to use this. So, chain rule is applied when you are given a composite function or function of a function. Say we have y equals f of g of x. Your outside function f, it's also called outer function, and whatever you have inside g of x, it's called the inner function. So, your y is a composite function, meaning it's made of another function g of x. Now, chain rule actually says, in order to find the derivative of this composite function, first thing to do is just take the derivative of outside function f prime, leaving the inside function g of x alone, untouched, times the derivative of inside function g prime of x. So, verbally, in order to find the derivative dy dx, we want to differentiate the outside function f, leaving inside function alone as is, gets multiplied by the derivative of inside function. Now, as a quick side note, why actually it's called the chain rule? Because sometimes you are given more than one function inside of your bigger function, so you will get the small derivatives being multiplied, so you will get a chain of small derivatives being multiplied together. That's why actually it's called the chain. Now let's move on and put it to the test. Say we need to find the derivative dy dx of 2x minus 1 cubed. So first of all, we should recognize that this is a composite function. So you have a power, which is the outer function, and you have something inside, which is 2x minus 1, and which is a linear function. So it's a perfect candidate for using the chain rule. Now, according to the chain rule, first thing to do is just take the derivative of outside function, which is power. So we want to bring these 3 outside as a coefficient, so 3 comes out front, and we want to reduce your power by 1. 3 minus 1 becomes your new power, and you want to keep this 2x minus 1 inside as is, untouched. And we are not done yet, so by the chain rule we have to multiply this by the derivative of 2x minus 1. So all you want to do is just clean it up. We want to simplify this expression. And remember, the derivative of 2x minus 1 is just 2, since the derivative of negative 1 is just 0, derivative of any constant, and the derivative of 2x is just 2, so x goes away. And the last step, we want to combine these 3 and 2, so the product becomes 6. 2x minus 1 squared. That's your final derivative. This example can be generalized. Say we have expression ax plus b raised to the nth power. So let's differentiate this. Again, we are going to use the chain rule. So first step, take the derivative of outside function, which is power, by applying a power rule. So this n comes out front, and reduce your power by 1. So new power becomes n minus 1, keeping inside function alone. So ax plus b. And this expression gets multiplied by the derivative of ax plus b, which is a. So a times n comes out front as a number, as the coefficient, and we have the rest. So you could think of this as a separate formula, but to be perfectly honest with you, I wouldn't recommend to remember this as a separate rule, since you can always derive this derivative from scratch. Now let's have a look at another example. Say we have 2x plus 3 to the 4th power, and we need to differentiate this function. So precisely the same steps. So it's a composite function, definitely, and we are going to take the derivative of the power first. So 4 comes out front, you reduce your power by 1, knock it down by 1, keeping inside function as is, 2x plus 3. And this expression gets multiplied by the derivative of 2x plus 3, which is just 2. So, since 4 times 2 is 8, so you will get your final derivative. So, there are some problems to carry out. More? That's all.